Hello everyone. We're looking at Unit 8 Practice Exam version number 2. So looking at our first question, it says state the common ratio of the sequence. So automatically they prompt us, they tell us it's a common ratio. So what we need to remember is that in order to find the common ratio, it's always going to be any term divided by its previous term. So in this case, we don't have to check all three of these values. We can just pick any two and then go from there. So I'm just going to pick the first two just because it's most convenient. So it's going to be 3 over 4. And then again, we divide by its previous term. So what comes before it is negative 1 over 2. So again, when it comes to the negative values, you can put the negative in either numerator or denominator. It doesn't matter. All that matters is that it exists only once in the fraction. So remember, when we divide by fractions, that's the same thing as multiplying by its reciprocal. So we have 3 over 4 times 2 over negative 1. And from here, we can cancel out the 2 in both numerator and denominator by giving us 1 and 2 respectively. Because again, we're just dividing by 2. And so that gives us our final answer of 3 over negative 2. And then we can use this answer just to double check if that is true. If I were to multiply negative half by negative 3 over 2, would that give me the next term? Yes. And then so on and so forth. It is also true. So looking at number 4 says, what is the formula for the nth term of the sequence b shown below? So b, we see 10, 12, 14, 16. So right here we can see that there does exist a rule of addition by 2. So the moment that we see its addition by 2, what we can eliminate right away is answer choice 3 and answer choice 4. Because notice that they have exponents as such. So what that tells us is that there's repeated multiplication relative to repeated addition, which is what we want. So if we were to write a formula based from scratch, we know that we always start off with the first term 10, and then we keep adding 2 and minus 1 times. But if we look at our answer choices, neither of them look like this exactly. But what we can do is manipulate this by distributing a 2 to each term, thus giving us 2n minus 2, or in other words, 8 plus 2n. So that gives us our answer choice number 1 as such. Another way that we can check it is realizing that if this is our first term, that's going to be, in this case, b sub 1. So if we were to substitute 1 for n, in this case, 8 plus 2 times 1 will give us 10, but the other formula, 10 plus 2 times 1 will give us 12, which is not the first term. So number 2 is wrong. Now if we look at number 3 says, when a ball bounces, the heights of consecutive bounces form a geometric sequence. The height of the first bounce is 121 centimeters, and the height of the third bounce is 64 centimeters. To the nearest centimeter, what is the height of the fifth bounce? So let's just extract what we know. We know first bounce is 121, and third is 64. So because this is a geometric sequence, once again, we should remember that there exists a common ratio. So to find the common ratio, as per usual, we take our term, so let's say 64 divided by 121, and then we think about how many times is the common ratio applied to get from a sub 1 to a sub 3. So in this case, our common ratio is applied twice as such, 3 minus 1. So again, the reason why it's 64 over 121 is because, well, we're trying to think what times 121 will get to 64. And so that's why we have this as such. And also realize that the values are decreasing. So whatever our common ratio is must be less than 1. So therefore that gives us 64 over 121 equals r squared. And so from here, if you were to type this into the calculator, it might have been quite ugly. So again, I would just leave it as a fraction. And if you want to convert your ugly decimal into a fraction, we would have to just press math and then frac. So from there, to isolate r, we just take the square root on both sides, thus giving us r equals 8 over 11. And so we need to find the common ratio here because we need to know what rule to employ in order to find the fifth bounce, or in other words, a sub 5. So to find a sub 5, you can either just multiply this original third term by 8 over 11 twice, or you can just use a formula that is given to you on the test. So to find a sub 5, we're starting off at a sub 1, which is 121, and we repeatedly multiply by 8 over 11, in this case 5 minus 1 times. Because again, to get to a sub 1 to a sub 5, we're repeating this rule of multiplication of 8 over 11 4 times. So that thus gives us, in this case, about 34, and that's our answer choice 2. Now let's look at number 4. Number 4 says, Jasmine decides to put $100 into a savings account each month. So $100 into a savings account each month. The account pays 3% annual interest compounded monthly. How much money, S, will Jasmine have after 1 year? So this is quite annoying because we see that these units of measurements are all in different measurements of time. So if they're asking us to find how much money Jasmine will have after 1 year, what we need to utilize is our geometric series formula. So from here we know that, well, a sub 1 is 100 because that's the initial value, and n is equal to 12 because 1 year is the same thing as 12 months, since everything in here is in terms of months. And so if we look at the growth R, it says 3% annual interest, but it says compounded monthly. So even though it might seem like we just multiply by 1.03, we have to remember that 3% annual interest, if it's compounded monthly, it means we divide by 12, thus giving us 0.0025 per month. So again, because it's growing, we're going to have to add 1, thus giving us R is equal to 1.0025. So if we were to follow our geometric series formula, that's therefore going to give us answer choice 2 right there. And that's it. Okay, let's move on to number 5. So number 5 says, oh, before we move on to number 5, I made a typo here. Answer choice 1 and 3 is exactly the same. Instead of half times g sub n minus 1, I meant to write 2 times g sub n minus 1. So right off the bat, number 5, we have a recursive formula. So the moment that we see that phrase, we know for sure that a recursive formula includes 2 equations. So automatically, we can eliminate answer choice 2 and answer choice 4, because those are only singular equations, which represent explicit formulas, not recursive. All right, now so from here, if we read what's happening, this is saying, okay, our first term is 18. True, that is true. And then to generate any other term, we multiply half to its previous term. So let's see. Previous term times half is 9. Yep. Previous term times half is 4.5. Yep, that is also true. So that leaves us with our answer choice 2 as such. Now another way to determine, in this case, our common ratio, once again, is to take any term and divide by its previous. So any term divided by its previous, 9 over 18. Any term divided by its previous, so 4.5 divided by 9. And if we were to simplify that, that would give us half. So that's another way to verify if that is indeed true, that there exists a common ratio of half. So moving on to number 6. Number 6 says, a town library initially has 54,000 books in its collection. So right off the bat, that gives us one of the most important pieces of information. Then it says, each year, 2% of the books, 2% of the books are lost or discarded. And then the library can afford to purchase 1,100 new books each year. So again, now it says, write a recursive rule a sub n for the number of books in the library at the beginning of the nth year. So now notice this, it says the beginning of the nth year. So as per usual, we want to think to ourselves, are we using a sub 0 or a sub 1 now? So if it says a sub 0, that's saying at the beginning of the 0th year, relative to a sub 1, which is the beginning of the first year. So that's essentially what's happening, the beginning of the first year. So beginning of the first year, nothing has happened. And then after, what was I saying? Okay, so once again, a sub 1 is the beginning of the first year. And then a sub 2 is the beginning of the second year. So the beginning of the first year, none of this has happened yet. So that's why we're going to denote our first term as a sub 1 equals 54,000. Because at the beginning of the first year, this is what the library is starting off with. And then the beginning of the second year is when we start applying all these operations. And so once again, if it's recursive, we have to write 2 parts. Define our first term, and then now how do we define all future terms? So we have a sub n equals So we have 2% loss of books. So if we have 2% loss, that means we're keeping 0.98. So we have 0.98 times its previous year. And then because we're including a purchase of new 1,150 books, that's why we plus 1,150. So in English, this is saying, I'm starting off with 54,000 books. And to find the number of books in any other year, we multiply the previous year's number of books by 0.98 to show a loss of 2%. And then we're also increasing the number of books by 1,150. And then now it says, determine the number of books the library will have at the beginning of the third year, round to the nearest whole number if necessary. So this is, once again, where we have to find all terms before a sub 3. So we already know a sub 1 is 54,000, and because it's recursion, we cannot just jump into a sub 3. We have to find a sub 2. So a sub 2 is the same thing as 0.98 times, again in English, just saying the previous term. Previous term is 54,000 plus 1,150, giving us 54,070 books. And then lastly, to find a sub 3, we do the same thing, 0.98 times the previous term plus 1,150, thus giving us, and again, because we're talking about books, we're going to have to round to the nearest book, so we're going to say this is at the beginning of the third year, the library has about 54,139 books. Okay, number 7. Determine if the sequence below is arithmetic, geometric, or neither. Justify your answer. So as per usual, we have to determine, well, is there a common ratio or a common difference? And I just mixed up the two in terms of order, but it's okay. Okay, so to find common difference, remember we always take any term and subtract its previous. Any term, subtract its previous. So if we do all of those three operations, any term subtracted by its previous, we're going to see there's a difference of -7, -7, and -6. So again, in English it's saying -7, -7, -6. So the moment that one of them is different, automatically we know there is no common difference and it's not arithmetic. Now if we try the common ratio, it's the same idea. We want to see if the ratio between each terms are the same. So we have any term divided by its previous, 18 divided by 25, 11 divided by 18, 5 divided by 11. And if we type that into the calculator, they're not going to be the same. So once again, because there does not exist a common difference or ratio, it's automatically neither. So let's move on to number 8. Number 8, a 7-year lease for office space states that the annual rent for the I can't read today. The annual rent is $85,000 for the first year and will increase by 6% each additional year of the lease. Use a formula to find the total rent expense for the entire 7-year lease. So automatically, every time they say that keyword of like total, they're just saying how much money are we paying for the first, second, third, fourth, 5th, 6th, and 7th year all in total. So that indicates to us we're going to have to use a geometric series. But how do we know it's geometric? Because it's saying that we're increasing by 6%. So that means that it depends on what the previous year is, and we're multiplying because we're not adding a constant value. So we need to know 3 things. We need to know a sub 1, the common ratio, and the number of terms. So our first term is 85,000 because that's where we're starting off at. And again, if we're increasing by 6%, we're adding that on top of the 100%. So therefore, we're multiplying by 1.06. And for a total of 7 years, n equals to 7. So this is the formula that will be given to you on the test. And so once we know that, all those 3 pieces of information, we just substitute that in, giving us our final answer of $713,476.20. Even though it doesn't say to round in any way, because we're talking about money, it would make the most sense just to round to the nearest cent. Moving on to number 9, it says, In a geometric sequence, the 6th term is 1,215 and the 10th term is 98,415. Assuming the common ratio is positive, write an explicit and recursive formula for the nth term of this sequence. So this is kind of weird because they're telling us the common ratio is positive. Now, it wouldn't really make sense until we start doing the problem. So let's start. So they tell us that the 6th term and the 10th term are as such. So once again, if there's a geometric sequence, then we know for sure there's a common ratio. So we want to find what is the jump from a sub 6 to a sub 10, and so that would be its quotient. So 98,415 divided by 1,215, and then we say we want to think to ourselves, how many times does the common ratio apply between the 6th and the 10th term? So that would be r to the power 4, or in other words, 10 minus 6. So once we do that, that's going to give us 81 equals r to the power 4. So once again, in English, it's saying from the 6th term to the 10th term, we multiply 81 by 81. But if we're applying the common ratio 4 times, we're trying to think what number multiplied by itself 4 times will give us 81. And so in this case, this is where we have to take the 4th root as such. But once again, if we're taking the 4th root of a value, that's why, or any even root of any value, we're always going to have plus minus. So that's why this problem says, assuming the common ratio is positive, because the common ratio could be negative as well. So assuming that it's positive, r is equal to 3. So again, in English, it's saying we take this value, and if we keep multiplying by 3, specifically 4 times, that will give us a sub 10. And you could check that on the calculator as well. So from here, now we need to know the first term as well. And so we could start off with a sub 6 and then keep working backwards. Or in case the numbers are uglier than this, we can just use the generalization as such. So this formula, the geometric sequence, explicit geometric sequence, is given to you on the test. So let's just use something that we know. So let's use a sub 6. So if we use a sub 6, we know that our common ratio again is 3. And if we're using a sub 6, then n has the value of 6. So a sub 6 again is the same thing as 1,215. So that tells us 1,215 is the same thing as the first term times 3 to the power 5. And so upon solving for a sub 1, that gives us a sub 1 is equal to 5. And again, that would be the same exact answer if you spent your time dividing by 3 5 times. And so from there, that gives us our explicit formula. So again, in English, explicit formula means one singular equation, and this is how we always want to read it. We're saying we're starting off with the first term, in this case 5. We keep repeating our rule of 3, and how many times do we do it? We do it n minus 1 times. Recursive is 2 equations, so we have a sub 1 is 5, and then now we have to describe what's happening to the previous term to get a sub n. So we take the previous term and then we multiply by 3. And that's it. Okay, move on. Alright. Number 10. Given the sequence 92, 80, 68, and 56, so it says write a formula for a sub n, the nth term of the sequence. So notice here, they don't tell us that it's arithmetic or geometric, and they also don't tell us if we have to write it explicitly or recursively. So that's up to us to decide, except for the fact that you have to determine if it's geometric or arithmetic. So let's see. So we're trying to identify a pattern that exists here. So you can use the same method as we did above, which is to either take any term and subtract its previous, or any term divide by its previous. And so here, this will give us our common difference of negative 12. If we keep subtracting by 12, that will give us our next term. So, as per usual, let's just start off with explicit formula because it's always easiest. We always start off the same way. What is our first term? In this case, 92. So we're starting off with 92, and then we repeat our rule of minus 12 n minus 1 times. That's it. We're done. So now it says write a series formula for the sum of the first n terms. So again, they're just asking us for the sum of the n terms, so we don't need to have a specific value for n. And because this is arithmetic, now we have to use the arithmetic series formula, and that's not given to us on the test. But as per usual, this is how we want to read it. We have S sub n, so the sum of the first n terms is the same thing as the number of terms n times the first plus our last term. So our first term is 92 plus our last term, which we don't know, is a sub n, divided by 2. And that's it. All right. And then so our last part, now they're asking us for a specific value, and they're asking us to find the sum of the first 50 terms. So the sum of the first 50 terms using the formula. So now we know that n is equal to 50. And so we already have the structure of our formula here, so why not just substitute? Well, we could, but again, we need to know our last term. So we're going to use the formula from the first part to find what the 50th term even is. So to find a sub 50, we substitute in n equals 50, thus giving us our last term, or our 50th term, is negative 496. And so our formula, now we can substitute in everything we know. So the sum of the first 50 terms is the same thing as 50 times 92 plus negative 496. So again, adding a negative number is the same thing as subtracting, dividing by 2. And continuing further gives us our final answer of negative 10,100. Now moving on to 11, it says, given the geometric series 300, 360, 432, and 518.4, write a geometric series formula for the sum of the first n terms, and use the formula to find the sum of the first 10 terms to the nearest tenth. So they tell us it's geometric series. So our goal right now is to find the common ratio. So as per usual, common ratio is just any term divided by its previous. Any term divided by its previous. So in this case, if they already tell us that it's a geometric series, we don't have to check all of them, but I'm just going to do so just so we can see there's multiple options to find the common ratio. So we can use 360 divided by 300, 432 divided by 360, or 518.4 divided by 432. And so if you were to simplify that on the calculator, that thus gives us r equals 1.2. If you want to write it as a fraction, that's okay too. It's the same thing. All right, so from there, now we can just solve. Now how? We know that n is equal to 10 because they're asking us to find the sum of the first 10 terms and to round to the nearest tenth. So we know a sub 1 is 300, so using those three pieces of information as per usual. So again, this is our general formula to find the, what was I saying? The sum of the first n terms. And so to solve this question using the formula to find the sum of the first 10 terms, we just substitute in everything that we know, and then that gives us our final answer of 7,787.6. Oh, wait, I just realized. It says to write a geometric series formula for the sum of the first n terms. So in that case, they would just want us to write S sub n equals our first term, so 300 minus 300 times 1.2 to the power of n, all divided by 1 minus 1.2. That's it. Because they're just saying this first n terms. So this is the first n terms, while this is the first 10 terms. All right, last question. What is the value of, once again, classic sigma notation? So over here, there's no shortcut, because if we look at our rule, it's neither arithmetic nor geometric, so we're forced to actually write out each term. Now, what do I mean by that? As per usual, we start off with, oh wait, I wrote it wrong. It should say x. LOL. Okay, so we have our first lower bound and our upper bound. So that means we're going to have to substitute in values of x from 0 all the way to 2, and we're substituting it into our rule as such, and that will generate our term. So if we substitute our values of x into the rule, this is what we have, and simplifying gives us 1, 2, and 1 respectively. So adding them all up, thus gives us our final answer of 4. And that's it. This entire expression is equal to 4. So that concludes version 2. I'm sorry if I spoke a little bit fast, so maybe you can slow down the speed of it, but I'll catch you in the next one. And if you have any questions, feel free to ask on Remind. Bye!